In this video, we are solving the equation cosine x equals 2 sine of x times cosine of x, and we want to express our final answer in radians. So this is a trig equation, and I would recommend starting by setting everything to 0, bringing all of the terms onto one side. So whether you want to subtract the cosine x to the right-hand side or subtract the 2 sine x cosine x to the left-hand side, that's up to you. I'm going to go ahead and just subtract the cosine of x over so that I have 2 sine of x cosine of x minus cosine of x. Now let me pause here and mention a common mistake that I see so that hopefully that'll help you avoid making this mistake in the future. Sometimes people want to divide both sides of the equation by cosine of x, something like this, and the result would be 1 is equal to 2 sine of x. And then they kind of proceed solving this equation. And by doing this, you will get one of the answers, but because you divided by cosine of x and that contains a variable x, you're actually losing a solution. So you will not get all of the solutions if you divide by cosine x. I always recommend when I'm working with students, I tell them never divide by a variable. Instead, subtract your terms over to one side of the equation. See if you can set that equation equal to 0, because then you want to try to factor. So in this case, I'd like to factor. I could see that we have two terms, and these terms have in common a cosine x. So we'll factor out cosine x. 0 is equal to cosine of x times 2 sine of x minus 1. And now that we have this in factored form, now that it is a product, it's multiplication, and because it's equal to 0, then we know that one of these two factors must equal 0. Either cosine of x is equal to 0 or 2 sine of x minus 1 is equal to 0. So that's called using the 0 product property. We're going to set each of those factors equal to 0. And then we solve these resulting equations. So for cosine x equals 0, we need to think back to our unit circle. So if we imagine our unit circle, which is a circle with a radius of 1, so we know that this coordinate here would be 1, 0. This coordinate would be 0, 1. Over here would be -1, 0, and down here would be 0, -1. And then remember, on the unit circle, when we look at these coordinates, the x value of that coordinate is cosine of the angle, and the y value of that coordinate is the sine of the angle. So in this case, when we're trying to figure out what angle, remember here in this case, x is an angle, what angle has a cosine of 0, then we're basically looking for where the x value is equal to 0. And there's two locations on the unit circle where the x value is equal to 0. So looking at the first angle would be this angle here, and that's going to be a 90-degree angle, but in radians, that's going to be pi halves. So our first angle we know is going to be pi halves. The cosine of pi halves is equal to 0. And then the second angle, if we go all the way around the circle down here, that's an angle of 270 degrees, but in radians, that's an angle of 3 pi halves. The cosine of 3 pi halves is also equal to 0. However, if you take a look at the directions up here, you'll notice that the directions did not limit you between 0 and 2 pi. So it's not just asking for the first angles that have a cosine of 0, it's asking for all of the angles. And there's an infinite number of angles that would have a cosine of 0. Pi halves and 3 pi halves are the first two positive angles, but we could keep going around and around the unit circle and we would end up with an infinite number of angles that have a cosine of 0. So the most succinct way of writing our answer in this case, our angle x, the first angle that has a cosine of 0 is pi halves. And then to get to the next angle, I'm going to change my color one more time to green. If I'm sitting up here at pi halves and I want to travel to 3 pi halves down here, I would add 180 degrees, which would be adding pi. And then if I was at 3 pi halves and if I added another pi, that would push me back around up here and I would land again at the same coordinate 0, 1. So we write this as pi halves plus pi times k, where k is an integer. So you don't have to use k. If your pre-calculus or your trig teacher taught you to use the letter n and write pi halves plus pi times n, that would be totally fine. But let me explain what that k means. That first angle was pi halves, the first angle we found. The second angle was 3 pi halves. So if we were to add another pi to this, if we were to add pi 180 degrees, that would push us up to 5 pi halves. So that would be another angle that also has a cosine of 0. And if I added another pi onto that, I would end up at 7 pi halves. And this process would just continue by adding. If I keep just adding pi every time, I land on another angle that also has a cosine of 0. We call these coterminal angles. But I could also go the other direction, and I could be subtracting pi as well if I wanted to go and find a smaller angle. And so that's why we write our angle like this. This gives me an infinite number of angles, pi halves plus pi k. Now let's move on to the other side. 2 sine of x minus 1 is equal to 0. To solve this equation, we need to add 1 and then divide by 2. So that will give us sine of x is equal to 1/2. So again, we are looking for an angle. X is an angle that has a sine of 1/2, a sine ratio of 1/2. Now, it is entirely dependent on how you learned your unit circle or your basic trig ratios. Some people learn to memorize the unit circle. Some people learn to memorize the triangles. That's a bigger discussion than what we have time for today in this video. But you need to know your reference angle. What angle has a sine value of 1/2? And that angle is going to be 30 degrees. So 30 degrees, if I were to draw a 30-degree angle here, that angle would be an example of 30 degrees. That's going to be pi over 6 in radians. And if you take a look at the triangle that results here from a 30-degree angle, we know that the radius is 1, because again, we're on the unit circle here. And the x value is going to be rad 3 over 2, and the y value here will be 1/2. So this coordinate on the unit circle that corresponds with 30 degrees, or pi 6, will be rad 3 over 2, sorry, that was a little messy, comma 1/2. And as we mentioned earlier, when we were looking at that unit circle, the x value is the cosine of the angle, the y value is the sine of the angle, and since we're interested in sine here, you can see that the y value of this angle indeed is 1/2, so we have the correct reference angle. So the first angle that has a sine of 1/2 is the angle pi 6, or 30 degrees. Now, we need to find the second angle that has a sine of 1/2. So again, if we're looking for that y value, then that would put us over here in the second quadrant, looking at this larger angle here, because once again, if we take a look at the triangle that corresponds with this coordinate on the unit circle, now my x value is negative rad 3 over 2, and my y value is still positive 1/2. So this coordinate is negative rad 3 over 2, comma 1/2, and you see the sine value is still 1/2. The y value will be positive not only in the first quadrant, but also over here in the second quadrant. So therefore, we need to find this large angle, this angle I'm demonstrating in blue, but yet the reference angle here is still pi over 6. So that little reference angle is still pi 6. So in other words, we're not going a full 180 degrees, but rather we're stopping short. Think of it like 180 degrees minus 30 degrees, which would basically be 150 degrees. But I recommend that you think in terms of radians. So we're doing full 180, which is pi, but we're going to subtract pi 6. So think of that as 6 pi 6 minus pi 6. That's 1 pi 6. And that's an easier way sometimes of landing on 5 pi over 6. So the second angle is 5 pi over 6. Now, in this case, if the first angle is pi 6, and the second angle is 5 pi 6, notice this is not like the last set of angles where I can just add pi to go from pi 6 to 5 pi 6, right? That would not give me 5 pi 6 if I were to add pi. So I cannot put both of these sets of angles together. I'm going to have to write them separately. So my first set of angles would be pi 6 plus 2 pi k this time. And again, that's because, draw my little picture. I'm going to scoot over. Once again, if I'm sitting here at a 30-degree angle, or pi 6, and then I want to find the next angle that also has a sine of 1/2 that's in the first quadrant, then I would have to start here and go all the way around once. That would be 2 pi, and then go up a pi 6 angle. So that's why we have pi 6 plus 2 pi k, because if I were to do that again, I would add another rotation all the way around, another angle of 2 pi, and land again at the same place. That will give me all those coterminal angles. But I have the second set of angles, which are in the second quadrant over here. So once again, my reference angle here, this reference angle is pi over 6. So this larger angle here is 5 pi over 6. So that angle would be 5 pi 6. But we would have to then go all the way around the unit circle one more time. That would be adding another 2 pi in order to land at the same place and find that coterminal angle. So my second set of angles is 5 pi 6 plus 2 pi k, where k is an integer. But since I already wrote that once, I don't need to really write that again. So what I have boxed here are the infinite solutions to this trig equation.